So the entire purpose of this video is to talk to you about tangent lines and slopes of tangent lines. I'm actually not going to do any examples in this video. There will be things you need to write down, but this is largely just us thinking through the idea and really breaking up some myths and some misunderstandings that we have about tangent lines. So I'm actually going to go through like 3 or 4 definitions. My first definition is not an entirely correct one, but it's what you guys all know. A tangent line to a curve is one that touches the curve only once. The reason I don't like this definition is that it's not precise. If I've got a curve like this and somebody says, oh, I want the tangent right there, like if your only definition was, oh, it only touches the curve once, I guess I'd put a line like that. Like, yay, look, I touched the curve only one time. Or, I could put it here, yay, I only got it once. Right? That doesn't work. And you guys all know, oh, no, the tangent is it's supposed to be like that, isn't it? But I know in the past I've even heard certain students who have trouble with this idea, because suppose you had a curve like this and somebody wanted the tangent here. You start graphing it like this, and you're like, oh no, it's going to hit again over here. So does the tangent line really only hit the curve in one place? I don't know. It feels like anytime we draw a line that only hits once, it might not really be a tangent line because it's just like cutting the function. And then when we really do have a tangent line, it might even hit the function twice. So it seems like the definition of a tangent line isn't really about how many points it hits. It must be about something else. So let's keep looking for a better definition. So here's our better but not perfect definition. A tangent line to a curve is one that touches the curve at one point and then follows the general direction of the curve near that point. And so that sort of means that's what lets us say, a tangent line isn't just like, woohoo, I hit once, because, at least you have to be going in the right direction. But it still doesn't answer the question of what happens when I have a curve that's like this. And this is the same example I showed you guys on the previous page. I can draw my tangent line like this, so that it sort of follows the direction of the curve, but it's still going to hit the function again over here. And so we keep coming back to the idea that, in my opinion, the fact that a tangent line only hits at one point is kind of is not that important. It's not the most important thing about a tangent line. There is something else. There is something better that defines what a tangent line is. And I'm going to be getting to that, right now. Alright, so here it is. I can give you a definition that is a lot more technical, but therefore gets to be a lot more precise. What a tangent line to a curve really is you find this tangent line by considering the secant line to the curve between 2 points. Now let's sort of wait there for a second. What I'm going to ask you to do to find a tangent line, let's say you've got a curve like this, you're going to think about a secant line between 2 points. Like, let's say that you really want to find the tangent at this point right here. That's really the one you want to find the tangent line for. You take a secant line, and what you're going to do is you're going to take the limit as the distance between those 2 points tends towards 0. So what that means is you're going to think about this secant line. And then you're going to say, well, what if this point was a little bit closer? Then I could think about this secant line. And then you're going to think, well, what if that second point was a little bit closer? Then I could think about this secant line. And I need another color. What if that second point, and maybe I even need to zoom in here. What if that second point was right here? Then I could have this secant line. And I recognize this graph here is sort of getting messy, but if I, maybe if I zoom out and we can look at this again, the point that I want to make is that if I take a limit as these points get closer and closer and closer together, I can find a tangent line. I can turn a secant line into a tangent line. And that's the definition of what a tangent line is. Coincidentally, it ends up hitting at one point right here. But it might hit at other points because the definition doesn't rely on it hitting one point. The definition relies on me taking a secant line and moving that second point closer and closer and closer. That's what a tangent line is really about. So the next question is, how do we find these tangent lines? How do we find the slopes of these tangent lines? And that's the last thing I'm going to cover. So here we go. First, just a notation for you. When I mention the slope of the line tangent to a function at c, so c is some x value on the curve, when I want to write the slope of a tangent line, I'm going to write this thing, f with a little, looks like an apostrophe. When you write it, it's often a little bit more slanted, like f that, and you read it as, oops, not x, f prime of c, right? So if you ever see this referred to in a problem, it's effectively referring to the slope of the tangent line. And here's my formula, right? We can find the slope of the line tangent to f at c by using this formula. And I don't want this formula to just be like a disembodied thing that you memorize. I want this to be something that we actually understand. And this is going to take me a minute or two, but this is really, really valuable stuff. Remember what I said on the previous slide. If I want to get the slope of a tangent line, what I do is I start by taking a secant slope. So let's think about that. A secant slope would be like f of b minus f of a over b minus a. And I actually want you to recognize that really quickly. Wait a minute, that this thing right here is saying a y-coordinate minus another y-coordinate over the x-coordinate minus the x-coordinate. This is just y2 minus y1 over x2 minus x1. This is the slope of a secant line. Now I'm going to do this sneakier, right? What I'm going to do is I'm going to say, you know, what if one of my points, what if one of the points of my secant line was f of c, right? So I'm just going to say, okay, one of the two, remember that a secant line requires 2 points, right? So one of my points is going to be at x equals c, and this is where I'm sneaky. My other point, I'm going to put at c plus h. Now what does that mean, right? What that means, this is amazing. I don't know if you can tell that I'm excited about this, but this is amazing, right? You've got this curve, right? Let's say that this right here is c. This is the point that you actually want to find the tangent for. Rather than going over here and saying, oh, here's a point b, it's another one, what I'd rather do is I'd rather say, this point over here, let's just say that it's c plus a little bit. This was c, I'm just going to go h further away, right? What that does is it lets me say I have a point at f of c and a point at f of c plus a little bit more, and then in the denominator I just have c plus h minus c. But then the c's cancel out, and what I have left is, I'm going to box this with a triangle, circle, triangle thing. I end up with that thing. And what's awesome is that that's the thing that I've been saying like for weeks. Back in chapter 0, it was like, oh, it's important, it's important, it's important, we're going to see it again. In chapter 1, we did limits. We're like, oh, here's a limit, here's this thing. And now, what am I doing? I'm taking this thing, which represents a secant line, and I'm taking the limit as h approaches 0. H was the distance between these 2 points. Like, oh my gosh. This is going to let me take these 2 points on a secant line, and it's going to let me draw the two of them together and let me get the tangent line, let me get the slope at only 1 point. This should be amazing. If it's not, it means you're missing something. It means you're not quite seeing the connection. And if that's the case, like, make a note, put a giant star, like a dark star on your paper, because I want to talk to you about it in class. I want to discuss that with you and get you a chance to see what this is really about. This video is a little bit longer than I wanted it to be, and we've got one more because I want to actually do some examples of how to do this stuff. This is just where it comes from. So I'll see you in the next one where we're going to do some computation.